Victor Mushkatin. I am CEO of VIAcode. In the past, I was running one of the Azure services called Application and Sites. And before that, sold my startup called evangelists to Microsoft. Together with me, this webinar was prepared by Daria Ganja, who is a software developer at VIAcode, and Arseny Vasiliev, who is a DevOps at VIAcode and was instrumental preparing this webinar as well. Couple housekeeping items. This webinar will run for about 60 minutes. The recording will be available, recording and slides will be available to all attendees at the end of the seminar. If you have questions, you should see a Q&A tab in the left lower corner of your Skype client. Please ask any questions and we'll do our best to answer them at the end of the webinar. At the same time, if you have a really burning question, you can speak up, and we'll try to answer as we go. Today, we will share our experience transitioning our clients to the cloud. What is a typical process or framework, rather, you go through in order to migrate your infrastructure and line of business applications? To illustrate this process, we're going to use our own service called MP Wiki. Using that service as an example, we will discuss the challenges people face when they made decision to move. So you decided to move to the cloud. What's next? The drivers to move to the cloud could vary. Your organization may be at the end of the lease on your on-premise hardware, or you might made a strategic decision to consolidate your multiple data centers into cloud to save money, or your business might grow through the hyper growth phase and you need additional scale and elasticity that you can get only in the cloud environment. Whatever the driver was, now you have the project on your lap and have all sorts of requirements and constraints. First of all, it needs to continue to run after the migration. So you need to manage risks somehow. Cost is a big factor too. You are pretty familiar how much your infra cost on-prem, but your manager is asking you to forecast how much would it cost in the cloud. In addition to cost, there are many unspoken expectations for cloud transition to cloud. Sometimes I hear that there is an expectation that cloud will unlock agility that you did not have being constrained by on-premise infrastructure, policies, and procedures. In order to proceed, you need to clearly identify migration goals, select the approach, and define the scope. We're going to highlight how goals affect the approach a little later using MP Wiki as an example. And now let's focus on different approaches you may take with respect to cloud migration. Generally speaking, cloud migration project can fall into either lift and shift or rehosting, where you take existing infra as is and move it to the cloud. Or you may refactor your application in order to capitalize on cloud scale, optimize your monolithic application to support more advanced billing models such as microservices and serverless infrastructure, etc. The decision is not black and white. Moreover, as we've seen with many customers, you may start with straightforward lift and shift, familiarize yourself with cloud, you spend some time observing the behavior, and then do the refactoring of the pieces you deem appropriate. Unless there are very specific requirements that necessitate cloud, for example, scale or storage capacity. This process is a balancing act between upfront cost of the transition versus management and maintenance cost while in operation. Regardless of the approach you take, migration scope can be broken down into the scope of infrastructure you're migrating from and to, and how you're going to monitor resulting cloud service. Usually, migration project starts with assessment of compute capacity needed to run your service, then evaluation of cloud storage options and connectivity requirements. Most pure rehosting projects focus on essentially right-sizing VMs in the cloud. It's not necessarily one-to-one relationship between the scale of your on-premise VM and VM size in the cloud. Cloud cost management is an important topic by itself. It will be covered in our future webinars. For now, the takeaway here is that you need to define requirements for your infra and map it to various cloud options to see which one would be the best match. Another point I want to make here is that monitoring used to be an afterthought for developers. It's sad but true. In the DevOps world, however, it is becoming part of an integrated service delivery process. It is important to consider your options for monitoring your cloud services well. Either you continue to use on-premise software to monitor cloud, or migrate to cloud-native monitoring. Another important aspect of that migration is how monitoring telemetry from the new service will be integrated into existing ITSM process. Monitoring exhaust can be rather big to bring it completely on-prem to do service diagnostics and troubleshooting. So availability and performance monitoring is also a big area, and like a cost topic, will be thoroughly discussed in future webinars. To demonstrate how we use this framework in real world, we're going to use a VIAcode own service called MP Wiki. So what is MP Wiki? It is a website where System Center administrators can learn how management packs are constructed. For those who are not familiar with System Center Operations Manager, it is an on-premise monitoring system where all monitoring knowledge encapsulated inside what's called management packs. Management pack contains data collection and data processing rules, alerting rules, monitoring views, etc. Usually, it is integrated with some type of ITSM system. Every time when Microsoft releases management pack, we update MP Wiki. By the way, many of those management packs that Microsoft releases, such as Azure MP, Office 365, Azure Stack, SQL Server, etc., are developed by us, by VIAcode team. System Center professionals around the world can view how MP works through a graphical representation of management packs entities. Let me show how it looks. So I'm going to mpwiki.viacode.com, and here you can see the list list of management packs. I see George wants to get a control. I guess that was by mistake. If you have any questions, George, please ask in our Q&A tab. So this is a list of management packs. And you can, as a System Center administrator, let's say I'm interested in how Windows operating system management pack works. I can select a version. Well, I guess it starts with an old one. I can see a graphical representation of this management pack. I can go into particular interesting area and dive into even some data collection properties. Okay, so essentially this website allows me to analyze how management pack was built so I can better fine-tune the monitoring criteria. MP Wiki had rather typical on-premise infrastructure. It was running inside the VMM cloud and was monitored, surprise, by SCOM. System Center Operations Manager. The service itself was hosted on two VMs. First VM was running a website, which is an old ASP.NET Forms application and a SQL Server database. Those images of management packs that you've seen during the demo, quick overview of MP Wiki website, are pre-generated and stored as files on disk on that VM as well. It's a VM2 on this picture. The second VM, VM3, on this picture, is the generation service. it is used to generate those images. This service is using some third-party software, namely Visio and Excel Office components, to generate those GIF files. When new MP is uploaded to MP Wiki, it kicks in the generation service, and all required imagery gets produced and stored on the disk. As I mentioned before, to start your cloud migration project, you need to define goals. Those goals put constraints on your analysis and govern the scope of migration. In our case, the main driver was our company transition from on-premise data center to the cloud. I was very price sensitive, because this is our essentially free service that we provide to the community. And I wanted to minimize both transition costs as well as operational costs. And I viewed operational costs as the time we need to manage infra, as well as ongoing cloud consumption costs. Taking those goals into account and understanding MP Wiki requirements, team took the project and went through roughly 3 stages. First, they created a list of required features for compute, storage, and monitoring, and mapped those features to various cloud options. Then, after analysis was done and selection of cloud service was made, team moved the data into the cloud and did a little bit of code refactoring to make it work. The last step was to make it all successful, to make it all work. Well, let me say that this was a perfect example of scope creep. While we were looking into implementing just monitoring options, we've decided to not only do the monitoring in the cloud, we've decided to improve internal processes, such as improvements to CI/CD pipeline and more detailed user usage analysis. While this was a scope creep, I think it was warranted in this case. Moreover, we see that usually clients, as part of cloud migration projects, try to address multiple issues, similar to what we've done with our transition. Now, I will let Daria to walk you through the migration process. Daria, go ahead.
Sorry, I was muted. Thank you, Victor. My name is Daria Ganja, and I will show the process we went migrating our project MP Wiki to the cloud. As Victor mentioned, we have started with analysis of our compute, storage, and monitoring options. For compute, we have considered app service web application, then service fabric-based microservices architecture. Most obvious lift and shift choice, Azure Virtual Machines, and tried and true Azure Cloud Service. Based on constraints such as low transition costs, we had to minimize code refactoring. Our ASP.NET monolithic application would have to be rewritten from scratch to support Service Fabric. So, that was not a viable option for us. Web applications would have been a great choice if there wasn't our requirement to support third-party software installation. MP Wiki generation service requires some Office components to be installed. This made web applications not a possibility as well. We were interested in minimizing operational and management costs. So we have 2 choices. The first one was to keep the application as is and use Azure VM. And the second one, to do a little code refactoring and transition to Azure Cloud Service. We compared these solutions and did a little code refactoring to transition our old MP Wiki to Platform as a Service. On the infra cost basis, both choices were on par, and we felt that long-term management savings outweighed little code changes we had to go through in order to support cloud service re-architecture. These requirements on this slide were not the whole list we observed. We've looked into things like access to Azure SQL database, ability to deploy code using Azure DevOps, native support for Azure monitoring, and so on. We found that they were equally supported by all considered options. At the end of the day, we made a choice to transition to Azure Cloud Service. As Victor mentioned, MP Wiki uses file system and SQL database. We've selected blob storage to transition files, as it was nicely integrated with Azure Cloud Service. SQL database transition, however, took us some time to investigate. There are a number of options with respect to transitioning your on-premises database. First off, Azure SQL database. It is a relational, high-performance, reliable, and secure database as a service, which means that we don't need to manage the infrastructure. Then we looked into managed instance. It is a fully managed SQL Server database engine hosted in Azure Cloud. Its deployment model is designed for customers who are looking for migrating a large number of applications from on-premises environment to fully managed platform as a service cloud environment with least migration efforts. And of course, we've looked into a plain SQL Server on Azure VM. Low operational cost requirement eliminated managed instance as a choice. It is cost prohibitive and clearly an overkill for such a small application as MP Wiki. Both Azure SQL Database and SQL Server on Azure VM have rather quick migration process. To achieve the goal of decreasing operational management, we chose Azure SQL Database. As this was the most involved step in our rehosting to the cloud, we are going to describe this migration step in more details. We've used Data Migration Assistant, known as DMA tool, for migrating MP Wiki database. Data Migration Assistant is a tool for migrating data from SQL Server to all versions of SQL Server, both on-premises and cloud. It allows to verify compatibility of the source database schema with target environment, and in many cases, autocorrect well-known incompatibility issues. It also generates schema deployment scripts and implements data migration. Let me show you how we migrated our database. Before migration, you need to create an empty target Azure SQL database, and I have already created it, my demo database. First, let's pick a project type. You can either run this tool to do the compatibility assessment or do the actual data migration with or without assessment. For our demo purposes, let's select Migration Project Type. And SQL Server as the only option for source database. While source database does not offer you any choices, Target Server offers several options, such as Azure SQL Database Managed Instance, and so on. Input source server name and appropriate credentials. Select Source Database and Assess Database before Migration option. Input target Azure SQL Database server name and credentials. Choose target database. Assessment workflow checks compatibility between source and target databases. And preparing source database schema. It represents also warning for the issues which are not migration blockers, but maybe they will not be supported on target server. For instance, behavior changes or deprecated types. And migration blockers will be marked by error icon. It also allows you to resolve known issues and generate SQL script. It creates scripts for deploying schema to the target server. Warning issues will be also included in this script. You can navigate through them using next issue and so on. It is possible to save this script and deploy schema. Deployment results can be exported in JSON file. It will be useful if you have deployment schema issues and you can attach it to your work item as schema deployment status. Only 400 left.
For some reason, nothing changes on my screen. Is there so it's moving on your side?
I don't see any issues.
Okay.
Looks good to me.
Okay. Expert.
So.
Okay. And migrate data. Migrate data creates a list of tables. Just select appropriate tables for migration and start. Details show data migration status and time. If there will be some issues, you will see warnings or errors. It is also possible to observe data migration using Azure Portal. It is represented in resource utilization graph or storage pie chart. Just reload it. And voila, we have done the migration. So easy, yep, at first sight. After we finished migration of the MP Wiki database, we discovered that nothing worked. And it was not due to schema incompatibility at all. The performance was so poor that it made site unusable. Queries that used to work just fine on a dedicated SQL with plenty of memory suddenly stopped working in platform as a service shared environment. If a server was hiding poorly written stored procedures and views, we had to spend some time optimizing queries and tuning Azure SQL configuration to bring MP Wiki back to acceptable level of performance. Once we made MP Wiki work, our last step in migration was to enable monitoring. We could not afford running production application blind. We had two choices, really. Keep some form of original SCOM-based monitoring and integrate it into Azure Monitor, or completely transition monitoring to cloud-native Azure Monitor. Of course, continue to use SCOM on-premises was rather logical solution, because we already had it. The only issue was that we would need to integrate SCOM alerting with Azure Monitor alerting. Somehow, there were two problems with continuing using SCOM either on-premises or in the cloud. First of all, existing SCOM alerting integration is not working. Victor later will talk about the product we ended up developing to overcome those limitations. In addition to that, SCOM Azure Services Monitoring has some issues as well. It is related to the per-subscription throttling implementation, and in case of large number of monitoring objects, you could exceed it. So, the most reliable way of monitoring Azure is Azure Monitor. Finally, after migrating to Azure Cloud, we got a new MP Wiki infrastructure. Cloud Service Web Role is used for hosting website, and Cloud Service Worker Role is responsible for the generation service. User logins and uploads management pack. This pack will be stored on the storage like a blob. When generation service starts to run, it downloads management pack from storage and generates content diagram, workflow tables, articles, and so on. All these files will be saved on the storage. Website communicates with it and represents links to these blobs. User information keeps on Azure SQL database. Monitoring via SCOM was changed on the Azure Monitor services, Log Analytics, and Application Insights. In the end, migrating to Azure helped us to achieve our goals. Migrate with minimal transitions cost and without re-architecting. During implementation process, team was faced the next problems. Migration tools were not enough. We used the DMA tool for migrating data, but we had to optimize it and find appropriate Azure SQL database configuration, which would not be expensive and fulfill our requirements. The next problem was the fact that Azure offers similar to on-premises objects, but they are not identical. For instance, on-premises Active Directory and Azure Active Directory. We created domain names for every wiki in old infrastructure, but we could not use it in Azure. One problem is that data transfer is time-consuming operation. Migrating 6 gigabytes of data to the Azure SQL database with 10 DTU took 2 hours. If Azure SQL database has 50 DTU, it takes only 51 minutes. Copying data from disk to the Azure Blob Storage also took a lot of time. That's all I wanted to share with you. Victor will continue with the analysis where we spent our time. Victor?
Thank you, Daria. So you've seen how we did migration of our SQL database from on-premise SQL to SQL Azure. It was very interesting for us to analyze where we spent most of the time during migration efforts. It was not a big surprise to see that old Pareto rule 80-20 work here as well. Essentially, roughly 20% of our rehosting efforts, were spent on rehosting, and 80% on operationalizing the service. As you see, analysis itself took about 10%. A little bit of cloud service refactoring and moving data like files and database took another 10 or 12%. The rest of the time, which was a lion's share of total time we spent on this project, was attributed to improving DevOps processes to support successful operations of this service. As I mentioned before, in addition to migrating monitoring to the cloud, we've decided to migrate our TFS to Azure DevOps and improve our user usage telemetry collection by augmenting Google Analytics-based instrumentation with Azure Application Insights. By the way, release automation in the cloud and user usage analytics are also pretty hot topic that will be covered in future webinars. To summarize the learnings from our experience, rehosting to the cloud, I would highlight the following. First of all, you need to carefully examine your priorities and understand how much and when you want to re-architect your application. This plan would help you get a clear picture how much you invest upfront versus ongoing expenditure. Second, most likely you will run into various data transfer challenges. It might be due to internet hiccups, transferring huge data files, or little incompatibilities in cloud versus on-prem services, similar to what we had with SQL. In any event, multiply time you think it would take you do the data transfer on pi, very scientific approach, and you get approximate estimation. And the last point, that most rehosting projects trigger additional improvements in your processes. Personally, I think this is a good time to revisit your DevOps practice and invest a little more into its improvements. So the process that we went through, as I mentioned, when we essentially increased the scope of our transition, migration projects to the cloud, where we invested into improvements in our CI/CD and improvements into user usage telemetry, it's a very, very typical processes that we see clients go through when they're moving from on-prem to the cloud. Last thing I wanted to mention is that while we were doing migration for ourselves and our clients, we wanted to preserve existing SCOM monitoring infrastructure and integrate it with Azure. Some of our clients have tens of thousands of VMs with thousands of management packs, and naturally the cheapest solution was to somehow integrate existing knowledge, monitoring knowledge that was implemented in a form of a management pack to Azure Monitor. It turned out that current SCOM integration through Log Analytics Connector and Alerting has a number of deficiencies, making it pretty much unusable for real operations. We ended up developing an extension to overcome those challenges and released it to Azure Marketplace. VIAcode SCOM Alert Management, essentially it's a free product, so no reason to not use it, that automatically creates true Azure alerts based on SCOM alerts. This allows you to disable those alerts, as well as integrate those alerts with with other system, let's say through webhook to, I don't know, ServiceNow. Also, it's a minor pig, but rather important. Our solution, SCOM Alert Management, propagates alert description to Azure Alert. So without this tool, when you receive alerts in Azure, the description will not be there. It will be in SCOM, but the text itself is not propagated into the cloud. So we fixed that issue as well. Anyway, I would recommend you all to, if you use SCOM and thinking to consolidate all your alerting in Azure Monitoring, to install VIAcode SCOM Alert Management and enjoy SCOM alerts inside your Azure alerting. Anyway, this is all we have to share today. Do you have any questions? Please speak up.
Yes, Victor, hello. There are a couple of questions that we already have on the list from our attendees today. So let me articulate some of them. So the first question is, I think this is related to Darius' part. It said, you said that low operation cost is not applicable for managed instance. Could you please explain?
Sure. There are two types of managed instance: general purpose and business critical. Estimated price value for general purpose is about $1,500 per month for the configuration of 8 vCores and 32 GB storage. As Microsoft declared, it is option for the most production workloads. Business critical is option for input-output and compute-intensive workloads. And you know, its estimated price value is about $4,300 per month for the same configuration. Our current price for Azure SQL database and all storages, also for monitoring purposes, is about $100 per month, so managed instance really was not an option for us. I hope now it's clear.
Yeah, thank you so much, Daria. Yeah, it's really not the super cheap solution, but I think benefits of managed services.
It looks like it's 15 times more expensive. Project, yeah. 15 times more expensive than for us than SQL Azure. So we compare like two options: 1,500 versus slightly over 4,000. So it's 15 to 40 times more expensive for us.
Yeah, it's a good point. Probably because we have IT team who can manage this service, and it makes perfect sense for us. But for some other customers, it might be different. Okay, so there's a next question. You said that external solutions, not Azure Monitor, cannot monitor Azure subscription efficiently. What do you mean? Could you please clarify it?
So regarding the per subscription, I believe, per subscription throttling limits, what are they?
Yes, you are sure, Victor. For each Azure subscription, Antonin Resource Manager allows up to 12,000 read requests, and per about 1,200, 200 write requests per hour. And These limits are scoped to the principal ID making the requests and the subscription ID or tenant ID. Our team faced these problems during developing management packs for Azure objects, and Microsoft changed it because early they had limit about 15,000 requests, and we are communicating with Microsoft team because we'd like to know the whole throttling algorithm and to know how we could resolve and overcome this issue.
So basically, as I understand, just to add to what Daria is saying, any external system has to go through an API to query the data. Those APIs have throttling limits. If the size of your Azure assets, number of objects, is big, you can easily reach those throttling limits and essentially be blind with respect to monitoring, because you will get throttled.
Yep, it's correct. But not Azure Monitor.
Yep.
Azure Monitor.
But not Azure Monitor, right?
Yeah.
So, any other questions?
We do not have any more questions from our attendees.
Okay. Thank you very much, and hopefully we'll see you soon when we will be presenting other topic as part of our Azure webinar series. Thank you.